In this video, I am going to discuss about different classification of pattern, pattern allowance and pattern material. Patterns are used for forming an impression in the sandcasting mold, and patterns always represent a model of a casting. The first step in any sandcasting process is making a model of patterns. So the main purpose of pattern in any sandcasting process is making an impression in the mold or mold cavity, and the patterns always represent a model of a casting. Commonly, wood or metal are used for making pattern in the case of sandcasting process. So we are going to discuss about what are the different classification of pattern which is used in the sandcasting mold making process. So we have a lot of classification. First one solid pattern, second one split pattern, third one match multi-piece pattern, fourth one match plate pattern, fifth one gated pattern, sixth one skeleton pattern, seventh one sweep pattern, eighth one follow board pattern, ninth one segmental or part pattern, 10th one loose piece pattern. So these are the classification of patterns which is used in the sand mold making process. So we can discuss one by one. So first one is the solid pattern. It is also known as single piece pattern. See, this type of patterns are commonly used when the product is very small and it can be withdrawn from the mold very easily. While we are using a single piece pattern, the entire pattern is contained in the drag portion. One of the surface of the pattern is always flat, which will be act as a parting surface or parting line. So this is an example for single piece pattern. Single piece patterns are commonly used when the casting is or product is very small, which can easily remove from the mold. The pattern can easily remove from the mold. The entire pattern that will be contained in the pattern entirely contained in the drag portion of the sand casting mold while mold making. And one of the surface of the pattern is flat, which will act as a parting line surface. So that is known as solid pattern or single piece pattern, which is commonly used for small sized casting, which can be easily withdrawn from the sand casting mold. And second one is split pattern or two piece pattern. Second classification, split pattern, or otherwise it is known as two piece pattern. See this pattern. So this is a two piece pattern for a dumbbell shaped casting. In this pattern is split into two half. The pattern is split into two half. This is a one half and this is the bottom half. This is the top half and this is bottom half. So in this pattern, the pattern is split into two half. One part is contained in the drag and other in the cope. The split surface of the pattern is the parting line of the mold. Two half of the pattern should be aligned properly by making use of a double pin, which are fitted to the top half. See, in the case of split or two piece pattern, the pattern is making by two pieces. One piece for cope portion and other piece for drag portion. And the split surface that act as the parting line surface. And these two pieces are aligned by using double pin. So this is known as split pattern or two piece pattern. And third one is the multi-piece pattern. See, multi-piece pattern means patterns are making more than two pieces. That means multi-pieces. These type of patterns are commonly used for complicated casting, in that the pattern cannot be removed easily. So this is an example for multi-piece pattern, which consists cope and drag. Instead of one more piece is there, one more part will be there, a middle portion that is known as cheek. So in this multi-piece pattern, while we are using multi-piece pattern, the mold consists three parts. basically three parts. So top portion is known as scope, bottom portion is known as a drag, and the middle portion is known as cheek. So multi-piece pattern are commonly used for complicated casting for easily removal of the pattern from the sand casting mold. Okay. Then match plate pattern. See, match plate pattern. This is the match plate pattern. See, in the case of match plate pattern, the patterns are made into two pieces. Patterns are made into two pieces. This is the one piece and this is the another piece. One piece is mounted on one side and the other on other side of the plate called match plate. So patterns are made in two pieces. One piece is mounted on the one side of the match plate and other piece is mounted on the other side of the match plate, and this is known as match plate. Upon that, the two half is fixed. Gate and runners are also attached to the plate along with the patterns. See, the gate and runners also attached to the plate along with patterns. After molding, when the match plate is removed, a complete mold with gating system is obtained by joining cope and drag. After molding and the match plate is removed, we have a complete mold with the gating system will be producing after joining the cope and drag portion. See, this pattern along with the match plate is commonly made up of some metals. Aluminium are commonly used for making match plate patterns. Okay, so that is the importance of match plate pattern. Then fifth one is the gated pattern. See, this is the figure of gated pattern. So what's the characteristic of gated pattern is? Gated patterns are commonly used for mass production of small sized casting. See, pattern of casting are connected to each other by means of gate forms. See, these are the patterns. These patterns are only used for mass production of small sized casting. And all these patterns are connected by means of gate forms. See, there will be a common channel that is known as runner through which the molten material is applying into the cavity. A common channel through which the molten material is applying into the cavity, and this common channel is known as runner. Okay, so that's the importance of the gated patterns. So gated patterns are commonly used for mass production of small sized casting, and all the patterns are connected by using a gate forms to a common channel that is known runner. Through this common channel, the molten material is applying into these individual cavities. Okay. Next one is skeleton pattern. See, the skeleton pattern are commonly not widely using. The skeleton pattern, that's a temporary setup made by using some wooden frame and strips. That's why it is known as skeleton pattern. See, skeleton patterns are commonly used for very large casting, easy shape, but only few numbers are to be required. It is not economical to make a large solid pattern of that size. In that case, skeleton pattern will be used. So the pattern is made of wooden frame and strip. That's known as, it is known as skeleton pattern. So it is filled with molding sand and rammed properly. After ramming, the surface sand is removed by means of stick. A skeleton pattern for a pipe will be shown below. So this is a skeleton pattern for a pipe structure. So skeleton pattern means the casting is very large, and if we require only few numbers, it is not economical to make a single piece solid pattern. In that case, skeleton pattern will be making. Skeleton pattern will be made by using wooden frame and strips. And after filling the sand, the sulfur sand is removed by a stickle and the pattern will be forming. Sand will be forming. Okay, so that is known as the skeleton pattern. Next one is sweep pattern. See, this is known as sweep pattern. See, sweep patterns are commonly used for preparing mold of large symmetrical casting, particularly of circular cross section. That's the important point. Where is the application of a sweep pattern? Sweep patterns are commonly used for producing mold for large symmetrical casting, particularly of circular cross section. Okay, particularly of circular cross section. The equipment consists a vertical spindle. Sweep pattern consists a vertical spindle. So this is the vertical spindle and a wooden template. This is a wooden template called sweep. That wooden template is known as sweep. The outer end of the sweep carries the contour corresponding to the shape of the casting. The outer end of the sweep. So this is the outer end of the sweep. That consists the shape corresponding to the casting. The sweep is rotated about the spindle to form the cavity. So the sweep that will be rotating about the spindle to remove the sand, and finally step by step the cavity will be produced. And after the cavity will be produced, the spindle and the sweep will be removed and this hole will be filled with sand and casting will be taking place. So that is known as sweep type pattern. And eighth one is the follow board pattern. See, follow board pattern means, see, this is a follow board pattern. Actually, this is a pattern and this is sand casting mode and this is the follow board. This is known as follow board. Follow board. And what in by follow board pattern? If the pattern is very thin, during ramming process, there is a chance that the pattern will break. So in order to avoid that problem, the pattern will be supported from the bottom by a wooden board that is known as follow board. In that case, the pattern is known as follow board pattern. So where we are using follow board pattern is, the thickness of the pattern is very small. During the ramming process, there is a chance that the pattern will break. In that case, the pattern is supported from the bottom by some wooden board. In that case, the pattern is known as follow board pattern. Okay. And ninth one is segmental or part pattern. See, this is the shape of segmental or part pattern. See, what's the main importance of segmental or part pattern is, which is used for making mold of large circular casting and avoid the use of sold pattern. Used for preparing mold of large circular casting and avoid the use of sold pattern of exact size. So it is basically a sweep pattern, but what is difference is, sweep will produce the entire cavity in single rotation. It will produce the entire cavity. By step rotation, the cavity depth will be increasing. Okay, but in segmental pattern, a portion of cavity will be produced. Then that will be placed another portion. Again it will be rotating. Another portion of cavity will be producing. In this way, step by step, the entire cavity will be producing. See, it have a pivot and a sweep. So it is initially placing over the sun casting mode and it will be rotating and producing the cavity. And the entire this entire pattern will be placing to another one point, again rotating, producing another part of the cavity. In this way, part by part or segment by segment, the cavity will be forming. That's why it is known as segment pattern or part pattern. So when compared to sweep pattern, what is the difference is, when the sweep is completing one rotation, the cavity will be producing for a certain depth. But here, while this part pattern or segmental pattern is completing one rotation, only one segment of the mold cavity will be producing. And after producing that segment, the pattern will be placing to another point and again rotating, and the cavity will be forming, portion of cavity will be forming. So in this way, part by part or segment by segment, the cavity will be forming. That's why it is known as part pattern or segmental pattern. And the last one is the loose piece pattern. Okay, loose piece pattern. See, this is the figure of loose piece pattern. It's very important pattern, loose piece pattern. Okay. See, by watching this figure, what's the purpose of the loose piece pattern? See, loose piece pattern are commonly used to produce an undercut or a small projection certain distance below the parting surface, which is used to produce an undercut or a projection certain distance below the parting surface. That's very important. See, here you can see that this is the sand casting mold. Here we require a certain projection, and the loose piece pattern that is used for producing this projection. See, initially these pieces, that means loose piece, form an integral part of the pattern during mold making. So this is the pattern, this is main pattern, and this is loose piece pattern. At initially, this pattern, this loose piece pattern is an integral part of the main pattern. Okay. After mold is complete, the pattern is withdrawn, leaving the piece in the sand. These pieces are later withdrawn separately through the cavity formed by the pattern. So during sand casting molding process, this loose piece will be initially an integral part of the main pattern and forming the sand casting mold. And this loose piece that will be removing from the sand casting mold initially, leaving this pattern here. And after that, this loose piece will be slowly removing from the cavity by some methods. So there will be a blind hole or projection will be producing. So this is the application of loose piece pattern. So loose piece pattern are commonly used for producing an undercut or a projection in a certain distance below the parting surface. Okay. So these are the classification of patterns. This is a very important topic. So what are the classification of patterns are? We have 10 classification of patterns. Single piece pattern or solid pattern, split pattern or two piece pattern, multi-piece pattern, match plate pattern, gated pattern, skeleton pattern, sweep pattern, follow board pattern, segmental or part pattern, loose piece pattern. So these are the classification of patterns. Okay. Next topic is pattern allowance. What is the concept of pattern allowance? See, if the patterns are making exact sizes casting, the casting size will be reduced, or it will be increasing or decreasing something. So some allowance are provided in the pattern. That allowance is known as pattern allowance. Some allowance are given in the pattern according to the design for the correct size of the casting. And the allowance are, we have 5 classification of pattern allowance. First one, shrinkage allowance, second one draft allowance, third one finishing allowance, fourth one distortion or camber allowance, fifth one wrapping or shaking allowance. So these are the 5 classification of allowance, pattern allowance. So we can discuss one by one what are the meaning of each allowance. So first one, shrinkage allowance. So before going to shrinkage allowance, what is the meaning of shrinkage? That's very important one. Actually, shrinkage is a casting defect. See, so during solidification of a casting, what is happening? The liquid metal that will be transferred into solid state by liberating heat energy to surrounding atmosphere. So during the solidification of a casting, inside the mold, volumetric shrinkage of the casting will be taking place. The entire volume of the casting will be reduced. Size of the casting will be reduced. And that defect is known as shrinkage defect. So in order to avoid that shrinkage defect, the pattern size should be little bit increased and the mold cavity size will be also get increased considering the shrinkage. So if the pattern size will be considerably increased based upon the shrinkage, the mold cavity size will be increased and after solidification exact size casting will be produced. That is known as shrinkage allowance. See, the patterns are not made the exact size as the desired casting because such a pattern would produce undersize casting. When pattern is prepared, certain allowances are given on the size specified in drawing so that the finished and machined casting produced from the pattern will conform to the specified size. That means when we are provided the shrinkage allowance, after solidification, exact size casting will be produced. So that is known as shrinkage allowance. So some extra material will be placed in the pattern and the cavity size will be little bit increased. After solidification of the casting, exact size casting will be produced. Okay. Next one, draft allowance. See, what is the purpose of a draft allowance? Draft allowance are commonly provided in the pattern for easily removal of the pattern from the sand casting mold. That's a very important point. What is the purpose of the draft allowance? Draft allowance are provided in the pattern for the easily removal of the pattern from the sand casting mold. So what do you mean by draft? See, in this figure you can see. First figure, in pattern draft allowance is not provided. In second figure, a draft allowance is provided. You can see if the vertical face, if we are not providing draft allowance, while the pattern is removing, there is a chance that mold wall will be tearing, rubbing. Due to rubbing, it will be damaged. Okay. When we are providing a small taper on the vertical face of the pattern can be easily removed. That taper is known as draft allowance. So what is the meaning of draft allowance is? Draft allowance is the taper which is provided in the vertical face of the pattern for the easily removal of the pattern from the sand casting mold. See, generally the size of draft is 5 to 30 mm per meter or average 20 mm per meter that is provided to the pattern. Okay, so that's the purpose of the draft allowance. Next one, machining or finishing allowance. The third allowance is machining or finishing allowance. See, the machining or finishing allowance means after the casting is prepared, if there is any machining operation will be there, grinding or milling, any machining operation will be there, we have to keep some amount of material over the casting. Otherwise, after machining, the casting size will be reduced. So in order to overcome this problem, the pattern size will be little bit increased considering machining allowance. So after the casting will be producing, the casting size will be little bit increased and providing some material for machining operations. And that allowance is known as machining or finishing allowance. So we can simply say that what is the meaning of machining or finishing allowance is extra material that is keep over the casting for any type of machining operation. Okay. So next one is distortion or camber allowance. See, distortion or camber allowance, which is always used to overcome defects which is caused by the cooling speed during solidification. See, during the cooling speed will be due to the high cooling speed, there is a chance that the casting will distort. See, this is due to the uneven shrinkage of the different part of the casting. So we are providing some allowance in order to overcome this cooling defects like warp or distort. That allowance is known as distortion or camber allowance. See, for an example, we have a U-shaped casting. For an example, we have a U-shaped casting. See, this is the actual casting, U-shaped casting. So after solidification, there is a chance that if we are not providing the camber allowance, these two legs will not be exact vertical. It will be move this like. That means instead of parallel, the casting have a converged legs. So this is the actual casting, a U-shaped casting which have two legs. So it should be exactly parallel. But if you are not providing the camber allowance, instead of it will be exactly parallel, the leg will be converged. So in order to overcome this problem, while we are making pattern, the legs will be in diverged portion. Legs will be in diverged portion in pattern. So after the casting has been solidified, the legs will be exactly parallel. So that is known as camber allowance or distortion allowance. Once more, see, we have a U-shaped casting. These legs will be exactly parallel. But if you are not providing camber or distortion allowance, after cooling or solidification, it will be not parallel, it will be converged. So while sorry the sorry uh, initially we have our objective is to produce a U-shaped casting. Okay, exactly legs will be exactly parallel each other. If we are not providing distortion allowance or camber allowance, what will be happen is the legs will be diverged. After solidification, the legs will be get diverged. Okay, so what will we do in order to overcome this problem? While we are making pattern, initially the patterns will be making in converged portion. Legs will be in converged portion. So after solidification of the casting, cooling of the casting, the legs will be exactly parallel and overcome this problem. Okay, so that is known as distortion or camber allowance. So the last one is the wrapping or shaking allowance. See, wrapping or shaking allowance, if the pattern is shaken for easily withdrawal from the mold cavity, the mold cavity size will be increased. So in order to overcome this problem, the pattern should be initially made slightly smaller. So for small and medium sized casting, this allowance can be ignored, but for large sized casting, these allowance are usually provided. So wrapping or shaking allowance, these type of allowance are usually provided for large sized casting. If we are shaken, while we are removing the pattern, if we shake, there is a chance that the mold cavity size will be increased. So the pattern size will be little bit decreased, and while we are shaking, the cavity size will be exactly formed. So that is known as wrapping or shaking allowance. So these are the 5 classification of pattern allowance. So we have first one shrinkage allowance, second one draft allowance, third one finishing allowance, fourth one distortion or camber allowance, fifth one wrapping or shrinkage allowance. Okay. Next one, pattern material. What are the different types of pattern material which is used in the sand casting mold making process? Commonly using material are first of all wood. See, patterns are made from a variety of wood. White pine is the favorite choice. White pine is the commonly using wood for making pattern. See, what is the importance of wood is wood will absorb moisture easily. So the pattern should be dried before used for making sand casting mold, because wood should absorb the moisture from sand casting mold, sand easily, and it will warp quickly. Okay. The next one is the metal. See, metals are commonly used in the case of mass production. So metal that will not absorb the moisture and it have ability to withstand high ramming force. See, metal patterns don't change their shape when subjected to moist condition, and aluminium and cast iron are the most commonly using metal. Aluminium and cast iron are most commonly using metal for making patterns. And third one is the polystyrene. See, polystyrene pattern that is commonly used in the investment casting process, precision investment casting process. Sorry, it is used in the polystyrene casting process, not for investment casting process. Investment casting process we are using wax pattern. Wax is also a material which is used for making pattern in the case of investment casting process. See, polystyrene pattern which is used for polystyrene casting process, this is a consumable pattern. Why it is known as a consumable pattern is when the molten material contact with the pattern vaporizes and leaving a cavity in the mold. So there is no required to remove the pattern from the mold in the case of polystyrene pattern. All other patterns should be removed. In the case of polystyrene pattern, when the molten material contact with the polystyrene pattern get vaporized, leaving a cavity. Into that cavity the molten material will be filled. So these are the common material which is used for making pattern. Apart of that, we are using wax pattern. So wax pattern which are commonly used in the investment casting process, that we can discuss later. So we have four material which is used for making pattern. First wood, second metal, third polystyrene, and wax pattern that I am not mentioned here. Wax pattern is commonly used for in the investment casting process. Okay. So these are all about the patterns. So today I am winding up in my video. In this class we have discussed about different types of pattern material, different classification of patterns, then pattern allowance, and different material which is used for making pattern in the case of sand casting mold. Okay, thank you.